Modern-day advancement in UAV technology has revolutionized the capabilities of drones, making them a more applicable solution to industrial and urban problems. S.A.U.L, or Surveillance of Agriculture by Unmanned Logistics, seeks to amalgamate multiple concepts of electrical and electronics engineering in an effort to streamline data collection and data analytics in the field of agronomy. Current agrarian solutions in agriculture lack the accuracy and speed the robotics can provide. Rapid global population growth demands higher yields from farmers. The need for cheaper and faster approaches to analyzing crop data is evident. UAVs can effortlessly enhance the efficiency of large industrial operations. Our system will be capable of acting as a critical support element for various points of interest in agriculture. S.A.U.L's development was split into two major stages. This gives our project an advantage in terms of marketing. Our client may interface their own UAV to work with our system. In other words, our data analytics system can work with various drones available in the market. Our hardware solution for the project is achieved through a combination of components. We use the PIXOC-4 flight controller with Q ground control to plan the path of our UAV. The UAV then captures images and videos required for data analytics. This data is then relayed back to the user computer. Our UAV is designed by interfacing a flight controller, a Raspberry Pi, a camera, and a 915 MHz telemetry system. To plan a mission or a path, we use Q ground control. This planned mission is then uploaded to the PIXOC-4 using a 3DR telemetry system. We are able to SSH into the Raspberry Pi while the drone is in the air to collect necessary images and videos required for data processing. We started with the consumer body and then constantly tweaked the model with custom prints to reduce the onboard weight. Countless experiments and tests have helped us improve the functionality of our UAV. We achieve object detection using a convolutional neural network. You Only Look Once is a CNN that splits the input image into grids. Each grid then calculates the bounds and confidence score for each objects. The model also generates a class probability map. If there is no object in the grid, the confidence of that grid is 0. The result is a prediction of the desired object to be detected. To prepare the model to our specifications, we first begin by annotating our dataset. These annotated images are then converted to YOLO compatible weights. Subsequently, the YOLO weights are then used to train the model. Once training is completed, we test the model with sample images. YOLO is a popular convolutional neural network model designed with the help of the Keras API. The stages of annotation, training, and detection are written in simple Python scripts. The advantage of YOLO is its ability to detect objects in real time. Custom data is saved and processed in specific directories of the project. At this stage, S.A.U.L only works with stored images. We aim to implement our design with real-time video. S.A.U.L will be further developed to tackle more complex analytics. We train S.A.U.L with a dataset of orange grove images. In the future, S.A.U.L will be able to tackle data processing of various crops. The market for agricultural drones is fast growing. We plan to tackle the market with a solution affordable to all farmers.